Hello, everyone. Glad to be here with you today, even though remotely. Today, I'll be speaking about technical debt and how to deal with it. My name is Katerina. I am co-founder of Adiva, which is a remote developers network. We help companies to scale their teams more flexibly with talent from all across the world. And I'm also a software engineer by profession and by heart, and Mozilla tech speaker. I've been consulting with startups and Fortune 500 companies for the past years. And if you watched any of my past Laracon talks, you know that I always want to combine my founder and engineer experience to find ways to be more productive and to bring more value both to the team and the customers. So this is the approach I'm going to take today with this talk, and try to find both the benefits and the downsides of leaving technical debt behind. What I'd like to start with is this quote that I found while preparing for the presentation, and it's, to me, the best definition we can have on technical debt. It says that technical debt is the coding you must do tomorrow because you took a shortcut in order to deliver the software today. So let's think about it. The coding you must do tomorrow because you took a shortcut in order to deliver the software today. And we all know we get the blame for taking shortcuts once in a while, someone more often, someone less. But still, it's not something that we do by choice. It's often something that we're constrained with. This is the endless balance, right? We're always trying to balance between writing clean code on one side and delivering features on time under aggressive deadlines on the other. And we often choose to ship fast without really thinking about the code we produce and considering if we need to go back to it and refactor it at a later point. And technical debt is what occurs as a result of it. So it's the amount of engineering effort that we'll need to do along the way due to the mediocre code that we've written right now. And it's often compared with financial debt because there is a limit to how much debt you can carry, and you always need to repay it at some point. What's concerning is that the average developer spends 42% of their time dealing with technical debt and maintenance issues. I know you can all relate to this. It can be trying to work on a new feature and then ending up using a function written a while back, either from you or by some other developer on your team. And you spend much more time trying to understand what this function does than you actually do writing the new code and solving the new problem. It can get frustrating, but over time it becomes a habit. So we're just used to it, and it's part of the job, right? The purpose of this talk is to show that it doesn't have to be that way, and how we can handle cases like this so that we are much more productive and will bring much more value both to the customers and to our teams in general, so making everyone's lives easier and better. So is technical debt always bad? It's not. Client technical debt can help you focus on delivering value. And I know a lot of you might roll your eyes at this because you don't think that leaving technical debt is something that can be considered useful, but bear with me here because there is some point to this. I will use a personal experience to explain this approach, which is a task we had to do a while back to integrate GitHub with Adiva's platform. This is something that I talked about briefly last year in my time-driven development talk. You can circle back to it if you want more detail. But essentially, this is the approach we took to pull data from GitHub to our developer profiles. The first thing we wanted to do is, of course, following solid. We want to abstract all dependencies so the controller doesn't care what happens under the hood. To do this, we used a combination of strategy and factory patterns to handle different Git clients. We figured that right now we are only working with GitHub, but over time we might want to integrate GitLab or Bitbucket or whatever else comes in the future. This type of architecture really helped us to isolate the concrete implementations of different clients and then have this abstraction that is like an umbrella for all of them, and made it easier for us to work with any kind of Git client down the road. The third thing we needed to do was to create an interface for the Git classes, and then create concrete implementations for all of them, starting with GitHub. And finally, create an adapter class that will adapt the response from the different API clients, and then return it in the right way that we need for our own system to work. And this was all good. It was working very well. It was thought through. We were considering all different scenarios, and it was fine, except that we ended up not using it. So we spent this time trying to create the perfect architecture, trying to implement the solution. And after a few months, we realized that at that point, at least, it didn't make sense for us, and we just abandoned it. Or as Dr. Ian Malcolm would say, we were so preoccupied with whether we could make this extendable, super maintainable solution without thinking whether we should actually do it and spend time on it. And this is like a textbook example of like why tech debt is good if it's left intentionally. So the right approach here would be to work on the simple solution that we needed at that point, test it out, see whether we are going to use it or not, and then over time get back to it and refactor it in a way that will enable us to use different clients in the future, or to maintain it or extend it easier. So when else is tech debt good? Working on an MVP, for example, that will probably need to be recoded after user feedback. So this is the approach many startups are taking today, lean development, lean startups. They are just building some basic version in the beginning, oftentimes even with no code required. It goes through user testing, they gather feedback, based on that they adjust. So at this point, it's very important to make sure that your vision as a founder is the same as what the users need. And after that process, the MVP is usually either recoded, or large parts of it are removed and replaced. So when you don't have a stable solution that you know that you will use over time, it doesn't make much sense to spend a lot of time upfront on writing this perfect architecture if it's going to be removed. So just try to go with the simple approach, write a simple solution, and then after you know what's stable and what's not, just go back to it, refactor it, or replace it with completely with new code. The example I just went through is kind of like an MVP within a larger product. So something we were experimenting with within the company. So whenever you need to experiment with new tools or features that don't have clear long-term value, we take the same approach as with MVPs. We go simple, we release it, we try to test it, whether it's internally or externally with clients or employees. And then decide whether it's something that we should use or not, and based on that, refactor afterwards, optimize the code, improve it, remove features that pieces of the code that are not necessary anymore, and deal with the technical debt at a later point. And this third one is something that we need to consider with caution. So new features or bug fixes that should be delivered fast, especially bug fixes that are critical, but also sometimes there's pressure from the sales team or from the customers. They need new features released fast, and we can't really think of creating this proper code design and spending more time on things that are not visible for them. It can be risky, but it's definitely something that's okay to do. So just work on whatever is the best way to solve the problem right now, deliver it, and then plan for coming back to it and tackle it later. We'll discuss about how to do it in a bit. But the main thing here is that it's okay to leave something behind as long as it's planned for in the near term. Something that you need to consider always is the common trade-off that spending less time now will cause you to spend more time later. This can be more time on the same feature, like for example with the GitHub integration I mentioned. So if we had to integrate GitLab, for instance, since the beginning, then yes, working on this more advanced architecture that enables us to work with different Git clients out of the box would definitely speed up the development. But in the case that we discussed, spending less time now meant that we will spend less time later because we wouldn't use the tool. So always consider the trade-off, how spending less time now will affect the future development, whether it will make things simpler or it will make the code more coupled and more complicated to maintain and extend on the long run. So here are the questions you need to ask yourself. Will leaving tech debt behind really make development faster, or are you being lazy? Because let's face it, oftentimes we just choose the simplest way regardless of the impact it has. So we should always think about how leaving the tech debt right now will impact the future development. As I mentioned just now, if it's something that we can do right now to speed things up and make it easier to develop later, then definitely take that chance, because oftentimes it doesn't need a lot to make it the right way. It just needs you to be in the specific mindset and think about it and work on it. Are there other features that depend on the same code base? If so, will investing a bit more time now save you time down the road? The GitLab example. So investing a bit more time right now, if we were certain that we're going to use these two different Git clients, would definitely make it easier to integrate the second and the third and all the rest afterwards. So just be mindful of this and make sure you answer all these questions before deciding on whether to leave the tech debt behind or not. And when does tech debt actually come back at you? So the first thing is with the planned technical debt that we were just discussing, it gets accumulated over time, and if it's not planned for handling afterwards, then it can easily come back at you and make your developers' lives miserable. So always plan for coming back to the technical debt that you left intentionally and sorting it out. The second thing is when unintentional technical debt creates craft in your code and makes development harder over time. And unintentional technical debt is debt that occurs when, for example, you're not following best practices in your daily development. So let's say you are handling all database logic inside your controllers, so they get bulky, they get long, and if you want to change something in the future, then you need to go through all these places where that table is used, for example, and adjust it everywhere. And it can get hard to maintain, it can get hard to release new features and especially changes. So this is also something that needs to be considered. It's often unintentional, and it's often even not noticed because maybe you're not familiar of good development practices, or you don't have coding standards within the team or naming conventions or whatever. So this is something that needs to be communicated within the team so that it can be avoided down the road. The third thing is that the code base becomes outdated as technology evolves. So this happens with the releases of new frameworks, for example, updates in programming languages, if you're not following them, if you're not upgrading accordingly, over time you can get to a point that's called a bit rot in software development. So your system gets so old and hard to maintain that the only solution out from it is full refactor. So how to look for technical debt inside your code? What are some signs that you can use to recognize whether you have technical debt or not? The first thing is bugs. Even if you have a single bug, then yes, you have some technical debt behind it. Maybe you're not considering or you haven't noticed. And this is especially interesting in regression testing, because finding a bug in regression testing means that your code is very coupled, and then working on a new feature right now messes up with something that was developed in the past. So be especially mindful about this. And if you notice anything like this happening, then go back to the code and try to understand what it does. So, and report it for tackling it as a technical debt. If you notice duplicate code and copy-paste approach to solving problems, you definitely have some technical debt inside your code. This can happen if, for example, to solve a bug or to release a new feature, you just copy and paste other pieces of the code without trying to create a more reusable structure. Or it could also, a sign for this would also be if you notice that when you fix a bug somewhere, it gets fixed in one place, but it's not fixed in another, then that's definitely a sign of a code that's not reused, and you need to go into all these multiple places and try to fix it multiple times. This one is more subtle, but it's also a problem and a red flag, because over time it can get much more difficult to maintain your code and to add new features. So if you have the case whenever you add new features, you need to go to your existing code and change it instead of add a new code, then this is definitely a sign for a technical debt that needs to, essentially you need to restructure your code so it's more abstracted, that you can always add new features by adding new code instead of by changing existing one. The reason for this is that whenever you go back and change existing code within your code base, you are making it more error prone. So let's say you have this core function that never gets changed, but it gets extended over time, and it's very well tested that over time it becomes resilient. If you're constantly changing it, that you can never get to a point where your the core of your system is stable. The fourth thing is not being able to understand what a function does. So when you need to work on a new task, a new feature, you open existing code, you try to understand what some piece of it does so that you can extend it with the new requirements, and then you realize that you spend much more time trying to understand this, what this function does, than you actually do working on the new code or solving the new problem. And finally, last sign of technical debt is slow performance, security issues, or unreliable data results. This is something that can be noticed from the performance of your system, and definitely needs to be considered and worked on, because it's something that your users also notice. How should we manage accumulated technical debt? So we went through when is that tech debt good, what happens when it gets back to us, but how can we manage it? There are three types of technical debt based on size. Small size technical debt, this is something that can be handled within the feature you're working on, so it doesn't need to be everyone can handle it independently, doesn't need to be planned within the sprint. To approach this, it's best to follow Uncle Bob's advice to always leave the code cleaner than you found it. This is based on the Boy Scout rule. That's why it's campground over there. But essentially, the point behind this is that you get to this piece of code. You've been there. Now you need to leave it better than it was before you move on. How this translates to actual coding terms. So basically, you always need to do simple code improvements as part of the existing tickets before delivering the feature that you been working on. For example, if you notice that some function is extremely long or uses some naming conventions that are hard to understand, try to improve just pieces of it. Maybe change the variable names so that every line of that function is easier to read and understand what it does. Or maybe just isolate pieces of that function in separate methods so that again, it can be easier to read, and if you need any specific details, you can then dig into the more specific methods. Whatever you do, the point here is to, based on the experience you had and what you understood while reading this function, try to make it easier for other developers who come after you, or for yourself when you come again at some point in the future, to understand this and make development faster for them. The second is medium-sized technical debt. This can be handled independently without disrupting the general workflow. So the most important thing here is to communicate it with the rest of the team. We know that businesses prioritize work that delivers value to the customer, and this is the right approach, except the problem is that managers fail to recognize the connection between code quality and customer value. So they often don't think that things they cannot see have any impact on the value the business provides to customers. And what's interesting is that the opportunity cost of bad code comes to $85 billion annually based on Stripe. And this is fascinating, and it's something that for businesses can really be meaningful to understand what the cost of not spending time on improving your code would be on the long run. So these are resources that could be put into delivering new features and creating value directly for the customers. With all of this said, how should we approach medium-sized technical debt? So the first thing that's most important is that everyone is on the same side, so things are communicated within the team, and time is dedicated to working with technical debt. So every engineer on the team should be empowered to report accumulated tech debt as they encounter it, and to plan a way for tackling that. The reported technical debt should be recorded, as well as the technical debt that's left intentionally during the given sprint. So that all goes to the backlog, and then the team should plan to tackle at least one backlog item per sprint so that you can have that momentum of constantly improving your code. Over time, it can make a massive difference for the full team and for the speed of development. Then we have large-sized technical debt. This is technical debt which can be handled during a single sprint and needs to be planned on the longer term. To approach this, the reporting is the same with the medium-sized debt. So everyone on the team should be on the same side, working on understanding and reporting the technical debt as they encounter it. And then all the senior engineers in the team should be involved in planning how to tackle the large debt. This, as I said, can be done in a single sprint, so it has to be handled over several sprints, and there are two different approaches you could take with your team here, both of them carrying some trade-offs, but based on the team dynamics that you have, one of them would be most appropriate. So the first approach is to create separate team to handle the refactoring, and this can be either internal or external team that would work only on the refactoring. one thing that's very important is if you separate your current internal team into refactoring and feature team, then it's very important that people who are working on refactoring are willing to do that and are not bored with the task. And on the other side, working with external team is not that intuitive, but we've had cases at Adiva where it worked like a charm. So clients decide to dedicate an external team to refactoring so that the core team stays focused on feature development. The approach can be good. The trade-off is that you will need to spend some time for the new team to understand the code structure, the business logic, and everything related so that they can work on improving the code, but not changing the business logic during the process. In either case, over here, it's important to have constant communication between the refactoring and the feature team so that you don't end up having both teams working on different versions of the code that can be become a mess very quickly. The second approach is to allocate time for every developer to do code refactoring. So everyone has some portion of their time that they dedicate to refactoring, and the other time is dedicated to feature development. I've had experience with this as well. So in a team that I worked on back in the days, we were dedicating Fridays to refactoring, and it was great. The only problem or trade-off here is that you can dedicate that time to feature development. So depending again on the team dynamics, on the speed that you need to deliver at, and the number of features that you need to deliver for customers, this can be tricky to manage, but if you have a nice development pace, then it's definitely better than creating a separate team for the refactoring, because in this case the developers who worked on some feature could actually do the refactoring and be much more efficient while doing that. Whatever you choose to do, just know that slow progress is better than no progress. So make sure that what you choose works for you and stick with it. Even if it's just an hour a week, it's much better than not having time for handling technical debt at all, because over time it will help you improve your code and make development much faster as a result. How can we avoid technical debt? The first step is to communicate. And there is this nice research that once you read it, it's very straightforward. So most of the bugs appear in files where the main contributor has made less than 60% of all edits after the initial release. So if you worked on a feature and then for all the changes, some of your colleagues were tasked to do it instead of you, then the chances are that there will be much more bugs than there would be if you would be doing all the edits. The problem here is, of course, we can't rely the full code on a single person. So the obvious solution is communication. Whenever you need to work on a fix or a change in a feature that you didn't develop, make sure that if the main contributor is still around, you discuss about the chosen architecture, maybe some things you need to consider before making any change, and make sure that your pull request is reviewed by that person to avoid the chance of having bugs or introduce additional technical debt without knowing it. The second thing is to consider the trade-offs when making design decisions. So whether what you're doing now will speed up development now and make it more difficult down the road, or whether if you spend some more time right now, it will make things easier for you and your team, and essentially make it easier to deliver features faster. So depending on the context, depending on the requirements, you need to consider the trade-offs whenever you are making design decisions, and understand the impact they would have. And always get in the mindset of considering long-term impact of your decision. So whatever you do has an impact, has a ripple effect. So it will come back at you or your team down the road. So you need to get in the mindset of considering that and make sure that your decisions account for the long-term impact. And before we wrap up, this is what I want to leave you with. So organizations who actively manage tech debt ship at least 50% faster. So if after this presentation you want to make a change in your company, try to discuss with your team about how to handle technical debt, and your managers are still not on board, this is something that you need to share with them. So both this and the cost of not handling technical debt is something that really resonates on business level, and will help your managers understand how important it is for the customer value. So think about it, make sure that you consider long-term impacts, you consider how bad code influences your development on the long run, but also keep in mind the benefits that technical debt, if left intentionally, can have on your team, and be more mindful about the way you approach software development. Thank you.